This video is going to go through the 7-1 warm-up and then the notes for 7-2. So in 7-1 we talked about using substitution and graphing to solve a system. So the directions here say solve by substitution or graphing. I'm going to do one by substitution and then one by graphing. So number one, if I look at this, I get 6x minus y equals 14, and then 2x plus 3y equals 18. So I'm actually going to solve this one by substitution. I'm going to solve my first equation for y. So negative y would equal 14 minus 6x, and then multiply everything by negative 1, and I get y equals negative 14 plus 6x. And then you want to take that and plug it into the other equation, into its y. So 2x plus 3 times negative 14 plus 6x equals 18. 2x minus 42 plus 18x equals 18. Combine my like terms, I get 20x. Add that 42 would equal 60. And then divide both terms by 20, or both sides by 20, and I get x equals 3. And then I'm going to take that, I'm going to plug it back into this equation. Y equals negative 14 plus 6 times 3, and I get negative 14 plus 18, which is positive 4. So my answer is the coordinate point, that is 3, 4. Now for number 2, I'm going to graph these. So the first thing I'm going to do is solve them for y. So 2y would equal negative 5x minus 1, and then divide both sides by 2, and I get negative 5 halves x minus 1 half for the first one. And then for the second one here, 3y equals negative x plus 5, divide both sides by 3, negative 1/3 x plus 5/3, or 1 2/3. So now I brought in my coordinate grid, and I'm going to plot those two lines. So the first one was negative 1/2 is my y-intercept. And then negative 5 halves means go down 5, 1, 2, 3, 4, 5, and to the right 1, 2. And then I'm actually going to reverse it the other way, so up and left. 1, 2, 3, 4, 5, and left 2. And then make as straight as a line as I can. And then go in and do the second one. So positive 1 2/3 is about there. And down 1 and to the right 3. Down 1 and right 3. Down 1 and right 3. Or up 1 and left 3. And this time it appears as though they cross right here. So this is a great example of where we didn't know it, but graphing was probably not the best bet. If we had done the other method of substitution, so I would have easily taken this one and set x equal to 5 minus 3y, and then plugged that into the x. I would have gotten 5 times 5 minus 3y plus 2y equals negative 1. 25 minus 15y plus 2y equals negative 1. Negative 13y on this side equals negative 26, and y equals a positive 2. So that looks about right. That is right there at 2. And then I would take this and plug it back into what I solved for x. X equals 5 minus 3 times 2, 5 minus 6, which is negative 1. Which, again, looks like that's about where we were at. So this point, which we just confirmed, was negative 1, 2. Was a little bit harder to see with graphing unless you're 100% accurate. You would have seen that line up a little bit better, but the way that we had drawn it, because that was where like 2/3 and 1/2 were our y-intercepts, it was a little bit harder to see. All right, then question 3 said, you're given the yearly interest earned from a total of $25,000 invested in 2 funds, paying the given rates of simple interest. Write and solve a systems of equation to find the amount invested at each rate. So just like yesterday's example, we've got an annual interest of $730. Rate 1 is 2%, rate 2 is 4%. So we know that to do the interest, we would say that 2% times, let's say that this is my X and this is my Y. So 2% times the amount of money invested at that rate plus 4% times the amount of money invested at that rate is going to equal the amount of interest earned, which is 730. And I can convert this to 0.02x plus 0.04y equals 730. And then the other piece of information was up here in the top that said the total investment was $25,000. So x plus y is equal to $25,000. So now I've got my system with these two here. Instead of graphing it, we're going to use substitution. So I can solve this bottom one. I can say x equals 25,000 minus y. And then I can take this and plug it in place of my x. But before I do that, I would probably choose to get rid of these decimals by multiplying by 100. So that's going to be 2x plus 4y equals 730, and add on your extra zero, so 73,000. Now take and plug this in. So 2 times 25,000 minus y plus 4y equals 73,000. Distribute the 2, so that would be 50,000 minus 2y plus 4y equals 73,000. 2y would equal, if I subtract 50 over here, I get 23,000. And then divide both sides by 2. Y would be 1, twice, 5, 0, 0. So 11,500 is how much was invested in Y, which is our 4%. And then if we want to solve for X, we would say that X equals 25,000 minus 11,500. Oh, too many zeros. And I get X equals 13,500. So if I was to write this out, they invested 13,500 at 2% and 11,500 at 4%. All right, now we're going to look at Chapter 7, Section 2, which is Systems of Linear Equations in Two Variables. Again, but this time we're doing elimination, so the third method that we're going to review. So solving using elimination, again, a lot of words here, but hopefully this kind of helps jog your memory, and if you get stuck somewhere, you can revert back to this. The first thing we're going to do is get both equations into standard form, which means the variables are lined up. And the constants on the other side of the equal sign. If needed, you're going to change one or both of the equations so that when you combine these equations, one of the variables will cancel out. Once you've done that, you're going to combine your equations. If you've done it correctly, one of your variables is going to cancel out. You're going to solve for the remaining variable and then plug it back into either the original equations or one of the ones we've altered, and then solve for the last variable. Just like with substitution, there's two special cases. If the variables cancel out and the statement is false, then it's no solution. If the variables cancel out and the statement is true, then it is all real numbers. All right, example 1. So solve using elimination. So you would look at this, your x's are in line, your y's are in line, your constants are in line. And then the question is, if I add this as it is, would one of my variables cancel out? Hopefully you realize it wouldn't, which means we have to alter this in some way. Easiest thing to do is probably look for positive negatives, numbers that are factors of others. In this case, I've got a negative y and a positive 3y, which means I can just multiply this by 3. I'd get 3x minus 3y equals 27, and then add it to the first one. I'd get 5x. These cancel, which is what's supposed to happen, and this would be 40. Divide both sides by 5, and x equals 8. Once I've got my first variable, I can plug it back into here, here, or even here, whichever one we altered. Make it as easy as possible on yourself. So if you plug it back in here, I get 8 minus y equals 9. Subtract the 8, I get 9 minus 8, which is 1. negative y, multiply everything by negative 1, and I get y equals negative 1. And I write it just like my solution set as before, 8, negative 1. Again, these are easy to check. You could take that solution and plug it back into both equations, and it should work for both. All right, example 2, again, same set of instructions, solve using elimination. If we look at A, this time, if I just add these, they're going to cancel out, so I don't even have to do any work. Add the two equations, I get 2y. These are going to cancel, equals 30. Divide both sides by 2. Y is 15. And then take it and plug it back into any of the ones above. So if I plug it in here, 15 plus x equals 20. Subtract the 15 and x equals 5. So my solution is 5, 15. Looking at B, this time I've got, they're not going to cancel right off the bat, and there's no way to change 2 to become 3 or 2 to become 5, which means this is one of those scenarios where you're going to have to change both. Again, it's up to you how you change it as long as they cancel out. So you want the same number, one to be positive, one negative. Because y is already one positive and one negative, I would tend to shoot for that, but you can always work with the x's. So let's say we're going to cancel out the y's. I'm going to multiply this top one by 5 and this bottom one by 2. So in doing so, my x, this becomes 15x. This becomes positive 10y, and don't forget to go across the equal sign. That becomes 20. Repeat that process here. 4x minus 10y equals negative 58. So if you've done it correctly, one of your variables should cancel out. I'd get 19x. These are going to cancel. Equals negative 38. Divide both sides by 19, and I get negative 2. Take that, plug it back in. This time you can plug it back into either one. I'm going to plug it back in here. 2 times negative 2 minus 5y equals negative 29. Negative 4 minus 5y equals negative 29. Add the 4. Negative 5y equals negative 25. Divide by 5. And I get positive 5. So my solution is negative 2, 5. And again, with extra time, you can take that solution and plug it back in to check it. Okay, now it says use any method to solve the system, which means you now have 3 to choose from: graphing, substitution, and elimination. Obviously, if you've got the graph paper, you can use the graphing, but it's probably not going to be your first choice. Then you would look to see, is one of the equations solved for a variable already? For example, if this top one had said x equals 21 plus 5y, then I would say that's set up for substitution. But because the variables are set up in line, one is positive, one's negative, it's going to cancel out. This is definitely an option for elimination. So if I combine these, I'd get 7x. These cancel, equals 42, and x would equal 6. And then take it and plug it back into either one. I'm going to plug it back into the top. 6 minus 5y equals 21. Negative 5y would equal 15, and y would equal negative 3. 6, negative 3 would be the solution you would get had you done it any of those methods. Example 4 is equilibrium point. So the equilibrium point is similar to your break-even point, okay? But this time it's asking in terms of supply and demand. So demand is how bad people want things or how many people want to buy an item, and supply is how much you have of that item. The ideal is an exact match. If you have too much demand and not enough supply, you run out of things. So if something goes out of stock or is on back order, that's because the demand is going to be stronger than the supply. If the supply is higher than the demand, that means that you've got a lot of inventory, wasted money. So you don't want that either. So ideally, the equilibrium point comes from setting the supply and the demand equal to each other and solving. So these are systems. They both have a P and they both have X. But they're both set equal to P. So if I wanted to just substitute this in for P, that would mean that 380 plus 0.1x would equal 500 minus 0.4x. So then I would multiply everything by 10 to get rid of my decimal. So 3,800 plus 1x, which would be x, equals 5,000 minus 4x. Combine my like terms, so I would subtract the 3,800 and add the 4x. I'd get 5x equals 1,200. Divide both sides by 5, and x would equal 240. Now that tells you the ideal amount of units you want to sell. So I'd want to sell 240 or have 240 units. The second part of this is how much do you want to sell them for? And that's what P represents, the price. So I'm going to take this and I'm going to plug it back in, and you can plug it back into either one, but a 0.1 times 240 is a little bit easier than a 0.4. So P equals 380 plus 0.1 times 240. 380 plus 24, which is 404. So ideally you would sell 240 units at $404 per unit. That is your equilibrium. We did solve this with substitution, but you can also solve this with elimination. So if I take and move that 0.4x on the side with the P, I would get P plus 0.4x equals 500. Do the same here with the supply. P minus 0.1x equals 380. And then I would want to cancel these out and also get rid of that decimal. So I can multiply the top by positive 10, and I can multiply the bottom by negative 10. And I get rid of my decimal. And also set it up to cancel out. So this would be plus x equals negative 3,800. Now these are going to cancel. 5x equals 1,200. And we're exactly where we were before. X is 240. Take it and plug it back into, again, any of them like I did before. And I would have gotten that P is 404. So this is at the point now that we've done substitution and we've done elimination, and you can pick between those, whichever one you're the most comfortable with. All right, last example. This is a minor league baseball team had a total attendance one evening of 1,175. The tickets for adults and children sold for $5 and $3 respectively, which means in that order. So here's my adults and here's my children. The ticket revenue that night was $5,087.50. A says, create a system of linear equations to find the number of adults and children at the game. Solve your system of equation by elimination or substitution, and then use a graphing utility to verify your solution. So let's start by creating the system. So we've got two pieces of information. Well, we have two subjects. A would be the number of adult tickets, and C is the number of child tickets. The first piece of information we're told is that the total attendance is 1,175, which means however many tickets I sold for adults plus however many tickets I sold for children adds up to 1,175 tickets. Now the next piece of information is how much they were each sold for and how much total revenue was brought in. So if each adult ticket is $5, then 5 times A plus each child's ticket, $350, equals $5,087.50. So again, you have got choices. You can either use substitution by subtracting the A or the C on the other side and then plugging into the second equation. Or I can get rid of the decimal on the bottom and then use elimination. So I'm going to do that method since that's what we're practicing this section. This is a 0, so I don't have to worry about it. I just need to move my decimal one place. So that's a 10. So 50A plus 35C would equal 50,875. Now, if I want to cancel this with one of these, then I can multiply while I do this next step. So I'm going to actually multiply by negative 50. Negative 50A minus 50C, and then 50 times 1175 that would be negative 58,750. Now when I add these are going to cancel. I get negative 15C, subtract 50,875 from 58,750, and I get negative 7,875. Divide both sides by 15, negative 15. And I get the number of children's tickets, 525 tickets. Now it said solve the system, so not only do I want to know how many children's tickets there are, I also want to know how many adults tickets there are. For that, it's definitely going to be easier to plug it back into the first one. So A plus 525 equals 1175. So 1175 minus 525, and I get the adult ticket number was 650. So my solution is, actually, let me write it out over here to the side. They sold 525 children's tickets and 650 adults. And then C says, use a graphing utility to verify your solution. So to do this, we're actually going to have to take these equations and solve them for one of the variables. It doesn't matter which one you make y or x as long as you're consistent. So if I say that A equals 1,175 minus C, this would act as my y, this as my x. Then I have to solve the second one for A as well. So I would get 5A equals 5,087.5 minus 3.5C, and then I'd have to divide everything by 5. And then let the calculator do that work for you. So 5,087.5 minus 3.5C, that's going to be my x, divided by 5. That can be typed in the calculator exactly the way that it is. So when I typed in my equations, which are here in the top, and I hit graph, this is actually what it looked like. I had a blank graph. And if you zoom out a little bit, like your normal negative 10 to 10, negative 10 to 10, you would still get a blank graph. So that's when you have to start to think about what it is you're graphing. If I'm graphing something like negative x plus 1175, that means my y-intercept is 1175. Also, if I'm looking for my intersection to be 525 and 650, I clearly have to zoom this out a lot. If you're adjusting your window, then you would need to adjust it around there. So what I did is just kept zooming until I got it into the viewfinder. And it looked like this. On the graphing utility on the calculator, or sorry, on the iPad, you can double tap the screen, hit intersection, and it will bring you directly to that point, which matches what we found up here, 525 and 650. Remember, on your handheld graphing calculator, you would hit second calc or second trace to get to the calc menu, hit intersection, and then highlight each line and let it guess, and it will bring you to that point as well. But again, you'd have to be in that window, so you have to make sure you're adjusting, thinking about what it is that the numbers that you'd be graphing. Okay, that wraps up. That wraps up the end of the 7-2 notes. You can use the remaining time to work on the 7-2 homework, which is on Canvas and WebAssign. Don't forget to submit your notes. Have a great day.